Okay, class, hi. The original lecture video, just set on my computer now. The original lecture video did not include the rest of our special senses chapter, so I'm coming at you live from my office. Well, not really live, it'll be a recording for you, but I'm doing this live for now. I'm going to not show the PowerPoint throughout this lecture because I like to draw a lot, as you guys know. And so in order to minimize the flip-flopping back and forth, I'm just going to be here. And I have my whiteboard here and my markers, and that way it'll just be easier. So you can follow along with the PowerPoint. We're starting off with the slide that's titled Vision, and that's right where the face-to-face lecture left off. So if you want to follow along with an actual printout, or you like to follow with the lecture guide, or however you choose to do it, that's where we're starting off. So we're talking about vision. So we had just finished going over the anatomy of the eye, which this week in lab, that's what we'll be going over. So it'll be nice for you to be able to put form and function together when we actually see the eye. We'll trace the pathway of light in lab this week, so it'll kind of make some more sense. But in the meantime, if you get through this lecture and you're like, oh, this is a bunch of words, I don't quite get it, clearly you have a quiz this week in class. Take a minute and go to YouTube and YouTube, visual pathways. How do we see? Look at the actual anatomy. Your textbook mastering has some videos in there, the AP Flicks, that would show you this pathway and help you break down and visualize vision. How ironic. So here we're talking about the rate and the distance and the direction of movement, all of these things, right? And you may recall learning about our brain. Of course, this is all done in the visual cortex. So just a little bit of physics for you, right? We see only a short, small segment of the entire electromagnetic spectrum. So this electromagnetic spectrum, this is things like microwaves and X-rays and gamma rays. What we can see is what we call the visible light portion. It is a very small window of that. And you may have seen other images of like what bees see or what snakes see with their infrared vision, and how they can kind of sense the heat in their prey animals, or how insects like butterflies and bees can actually see the ultraviolet light that's given off by flowers. So even though when you look at me, you see this orange shirt and my yellow hair, right? And you see these things, there are other forms of energy that we are giving off. We just can't perceive it. Our eyes aren't sensitive to those other types of radiation. Our body may pick those things up. Our body is sensitive to UV radiation. Our body is sensitive to X-ray radiation, but our eyes can't perceive it. So just because you can't see it doesn't mean that it's not there. It just means that our eyes are not sensitive to it. And so, of course, what light actually is it's energy wave, right? It's an energy wave that's carried by something called a photon. So a photon's like a little packet of energy that travels in a wave, right? We think of energy waves. Maybe you might think of the ocean, or sound waves kind of coming into our ear. We'll talk about those in a little bit. But light waves travel in the same manner with little packets of energy that we call photons. Slide 67 of your PowerPoint shows you the visible light spectrum. You don't have to know the wavelengths of any of those energies. You just have to understand what the EM spectrum is, and that we only see that small little piece there. So what happens when light comes in and passes through a medium? When it passes through a different substance, like when it passes from air to water or from air to our eye, right? It's actually going to bend. And that bending is called refraction. That refraction is what all of you that wear eyeglasses have, right? Refraction is that light coming in and bending when it hits another substance, another surface, right? And so that light comes into our eye, it passes through the cornea, it passes through the lens, and it refracts, it bends. That process of refraction is what helps our eyes focus on different things. And so it's this idea that you see on slide 69, and you've seen this on many things, right? When you look, say, for instance, at a fish in a fish tank, you'll see the fish from the side of the tank, and you'll be like, oh, the fish is right there. But when you look into the tank, you see that the fish was actually over here. That's because of refraction, that bending of the light passing through the water and then through the glass. I have to pause the video now because my cable guy is here. I will be back.